Today's lesson is 11.3, multiples. The objective for today is that I will find the multiples of a number. Vocabulary I want you to include in your notes says, multiple, the product of that number and any whole number. It's important for you to include what is written in red as well, that multiples never end. So typically, if we're solving problems figuring out multiples, you're going to be asked to look for a specific number of multiples for a number. And so we'll do some examples, but again, be sure to include this in your note. Don't forget that you can always pause at any point if you need to take extra time to write down definitions. Looking at this problem, there are 9 students in the chess club. The club wants to buy the same number of each item for each member. What number of items might the club buy? Well, they're going to buy 9 students' items, and they want to buy the same number for each item. We know that we're going to be buying multiples of 9, okay, because there has to continue to go up by the same number if each student is going to get the item. So I would look at my multiples. Well, just like we just said, the definition of a multiple was the product, which we know is the answer to a multiplication problem, of that number and any whole number. When I look at this, 1 times 9 is 9, 2 times 9 is 18. Okay, the answer's product, if I remember my definition of product, the answer to a multiplication problem. So all of my answers when I am multiplying times 9, all of the answers you see, so 9, 18, 27, 32, 45, 54, those are all the multiples of 9. So those are all examples of what number of items the club might buy. So another way to think about it is that this club, they're only going to buy 1 item per student, but they don't know how many they're going to buy. Every time it has to continue to go up by 9 every time, which is how multiplication works. And if you think about your multiplication charts, all of these numbers would be in the line on the multiplication chart. In your notes, I want you to go ahead and try this, listing the first 6 multiples of 7. Okay, so again, I just count up by 7. So I would have 7, and then I keep going 14, 21. But if you remember, this would be 7 times 1. This is 7 times 2. This is 7 times 3. And I would have 28, which is 7 times 4. And then I have 35, which would be 7 times 5. And then I would have 40. 7 times 6, 42. So I have my examples of the first 6 multiples of 7. So that would be the answer to this problem. Again, make sure you include that example in your notes. We're going to do a couple others together as well. We are looking at the first 5 multiples of each of these numbers. So I want you to include these in your notes. Looking at the number 1, it says 2. Well, the first 5 multiples of that would be 2, 4, 6, 8, 10. There's my first 5 multiples, and that's all I need to do. I want you to do number 2, so find the first 5 multiples of 9, and find the first 5 multiples of number 3, which is 3. Have those in your notes. We're going to look at number 5. For 5 through 8, it says to tell whether the first number is a multiple of the second number. Well, I'm looking at 14 and 2. So what this is asking me to do is look at this first number, 14, and ask if I did a multiple, if I went up by 2s, would I ever end up getting the number 14? Well, I know my multiplication facts, so I know that it is a yes, but I'm going to show you why. Because if I count it up by 2, I 2, 4, 6, 8, 10, 12, 14. Well, that works, so that would definitely be a thing that I could do. Another way to do it would be to think, well, 2 times something equals 14. Is that possible? If it is, then my answer is yes. So I'm looking at this one. Is 19 a multiple of 3? Well, I need to think about my multiplication facts. 3 times something equal 19. No. Go ahead and do the same thing for number 7 and number 8 in your notes as well.